This is the RQ-4 Global Hawk. RQ-4 Global Hawk is a high-altitude, long-endurance remote aircraft system, the biggest of its kind, and is manufactured by Northrop Grumman. It is built with an integrated sensor suite that provides intelligence, surveillance, and reconnaissance ISR capability. Being the biggest unmanned aerial vehicle, its main purpose is to provide a broad spectrum of ISR collection capability that supports the joint combatant forces in worldwide peacetime, contingency, and wartime operations. Northrop Grumman named this UAV RQ-4 for its main purposes. R is derived from the Department of Defense designation for reconnaissance, while Q means unmanned aircraft system. The number 4 refers to the series of remotely piloted aircraft systems. One of the world's premier surveillance and reconnaissance unmanned aircraft systems, the Global Hawk complements man-in-space reconnaissance systems by providing persistent near real-time coverage through imagery intelligence, signal intelligence, and moving target indicators, the Air Force go-to eye in the sky. What makes RQ-4 Global Hawk exceptional against its contemporaries and its counterparts in military surveillance? Let us find out in this video. If this perhaps is your first time watching our video, please do like it and subscribe to High Technology channel and find more of our interesting and latest updates on highly technological topics around the world. Let us meet the Global Hawk and its distinguishing features. Deployed operationally since November 2001 to support overseas contingency operations, Global Hawk is produced in 4 distinct blocks: Block 10, Block 20, Block 30, and Block 40. 7 Block 10 aircraft were procured but were retired from the Air Force inventory in 2011. 3 Block 20s were initially fielded with imagery intelligence capabilities. Updates made 4 Block 20s to be converted to an EQ-4 communication relay configuration carrying the battlefield airborne communication node payload. Block 30 is a multi-intelligence platform carrying electro-optical, infrared, synthetic aperture radar, and high and low band signals intelligence sensors. Currently, Block 30s are fielded with imagery intelligence sensors that support geographic combatant command as well as combat missions and operations Enduring Freedom and Iraqi Freedom. Block 40 carries the Radar Technology Insertion Program, or RTIP, Active Electronically Scanned Array Radar, which provides Synthetic Aperture Radar, or SAR, and Ground Moving Target Indicator, or GMTI data. Global Hawk is also powered by an Allison Rolls-Royce F137 RR100 turbofan engine, or otherwise known as AE3007H engine, with 7,600 pound force thrust and carries a payload of 3,000 pounds. Designed to fly at high altitudes of up to 60,000 feet, a single AE3007H engine allows the RQ-4 Global Hawk to fly at 65,000 feet, while providing over 32 hours of real-time mission imagery to battlefield commanders. According to military.com, a news and resource website for military members, veterans, and their families, Global Hawk is flown by a Launch Recovery Element, or LRE, and the Mission Control Element, or MCE. The LRE is located at the aircraft base and functions to launch and recover the aircraft during its flight. The MCE controls the Global Hawk for the bulk of the ISR mission and is manned by one pilot, but adds a sensor operator to the crew. Command and control data links enable complete dynamic control of the aircraft. The pilot workstations in the MCE and LRE are the control and display interface, or cockpit, providing aircraft health and status, sensor status, and the means to alter the navigational track of the aircraft. From this station, the pilot communicates with outside entities to coordinate the mission: air traffic control, airborne controllers, ground controllers, and other ISR assets. The sensor operator workstation, on the other hand, provides the capability to dynamically update the collection plan in real time, initiate sensor calibration, and monitor sensor status. The sensor operator also assists the exploitation node with image quality control, target deck prioritization, and scene tracking to ensure fluid operations. This system also offers a wide variety of employment options. The unmatched range and 30+ hour RQ-4 endurance allow tremendous flexibility in meeting mission requirements. In 2014, an RQ-4 Block 40 flew a 34.3-hour flight, setting the endurance record for the longest unrefueled flight by a US Air Force aircraft. This system has been proven in the skies over Afghanistan and Iraq. The system also provides an affordable and flexible platform for multiple sensor payloads to be used together, delivering mission-critical information to various users around the world. The altitude the Global Hawk can fly to is way more competitive than any commercial passenger aircraft that typically fly at altitudes of 31,000 to 38,000 feet or 9 to 11 kilometers. This drone can fly for up to 32 hours and has a range of up to 12,300 nautical miles or 22,780 kilometers. Measuring its length at 44 feet, a wingspan of 116 feet, and a gross weight of 25,600 pounds, the Global Hawk is comparable in size to the Lockheed Martin U-2 reconnaissance aircraft. In the early 2000s, both the US Navy and US Air Force bought Global Hawks. Northrop Grumman stated that the Air Force bought 37 Global Hawks in 2013. The Navy, on the other hand, has been buying MQ-4C Triton drones that have a 130-foot or 40-meter wingspan. These aircraft and the associated equipment accumulated a total budget of $473 million. RQ-4 Global Hawk made its first flight on February 28, 1998, and has since amassed more than 320,000 flight hours, with missions flown in support of military operations in Iraq, Afghanistan, North Africa, and the greater Asia-Pacific region. According to Northrop Grumman's website, Global Hawk sees potential threats to allow commanders to gain a greater understanding of an area of interest. These same intelligence gathering capabilities also allow civil authorities greater ability to respond to natural disasters, conduct search and rescue operations, and gather weather and atmospheric data to help forecasters predict the path of storms. As for the Global Hawk drone's update on its system, the Air Force and Northrop Grumman have been pioneering upgraded ground-based command and control systems to expedite man-machine interface to enable multi-platform interoperability, reduce latency, and provide a technical foundation for software upgrades. These updates are necessary to improve sensing range, image resolution, and data management. The Global Hawk ground station modernization program was said to be paving the way for interoperability with other Air Force systems and enhanced responsiveness. Increasing the ad hoc tasking of the Global Hawk leverages the new levels of emerging autonomy and on-the-spot mission adjustments made by advanced computer algorithms. These advancements can direct the aircraft to start its engine takeoff and conduct its reconnaissance mission with just a click of a mouse. It also incorporates new cockpit displays and emerging cyber hardening technologies. Aside from its records, Global Hawk is equipped with an electro-optical infrared camera that allows for day and night observation capability. Although this Global Hawk has set its records straight since deployment, the Air Force has raised concerns about its system. They believe that there is a need for the successor of this Global Hawk to be available sooner than later, since there are numerous modern air defenses and that the threat has accelerated much more in the past years. The Air Force also voiced concerns regarding the Global Hawk's intelligence surveillance and reconnaissance platforms, which they believe will be unable to deliver needed capabilities in the competition of modern times aircraft technologies. Hence, they recommended that resources should be invested in modern and relevant systems to ensure competitive aircraft and surveillance technologies against enemies. While RQ-4 Global Hawk has been a legend in the unmanned aerial vehicle, it pays to continuously update its system or create a better successor to fight the fast-changing and emerging aircraft technologies to maintain a greater advantage over the enemies. Thank you for watching and see you next time.